Hello everyone, welcome to the channel Coding Co. If you are a software developer or just someone diving into coding, you have probably heard the term design patterns more than once. But what exactly are they, and why do developers care so much about them? Or why do developers need to care so much about them? Think of design patterns as a tried and tested solutions to common problems in software design. Okay, emphasize these things like there are some common problems involved in designing a particular software. Okay, and these common problems are actually mitigated or resolved using tested solutions, repeatable solutions. Okay, they don't give you a code which you can actually do a copy paste, but they gave you a proven approach to structure your solution the right way. That's what the design patterns offers you. In this video and in this upcoming series about the design patterns, we are going to break down the most important design patterns every developer should be knowing, including some of them like Singleton, Factory, Observer, Strategy, and more. We'll not only explain what they are, but show you when to use them, why to use them with real world examples. Okay. So if you're ready to level up your coding skills and make your code more maintainable, scalable, and professional, hit the like button, subscribe, and let's get started. So, design patterns. Okay, so in software engineering, a design pattern is a general repeatable solution to a commonly occurring problem in software design. Okay, so this particular statement is extremely important that we I would suggest you to read multiple times. Okay, and register on your heart. Okay, so what does it says? It says that as part of the software design, commonly occurring problems can occur. Okay, so there are kind of a problems that can occur which is actually a commonly occurring one, and we just need to be aware that okay, so let's say I'm going to design this particular software and there is a problem or there are a lot of problems that are kind of like commonly occurring ones. Okay, what happens if you don't know about these commonly occurring problems? You will think that okay, this is an isolated one, let me put a fix on a particular bug, or let me put a fix on a particular issue for one time, and the problem reoccurs. Okay, and then you put a bug on some other bug fix on some other area, right? So what we need to be aware or need to understand is that this is a commonly occurring problem in software design. Okay, so when there is a problem we need to find a solution. Okay, now again, we don't have to find a solution in a, it's kind of like we don't have to reinvent the wheel, right? There are proven tested general solutions to these commonly occurring problems in software designs, and these solutions are actually the design patterns. Okay, so design patterns are created to solve the problems that occur over and over again in software development. That is a key thing that we need to understand over here. Okay, so it's something, it's before we actually move dive into like what are the different types of design patterns, there are how many design patterns are there, get into examples of each. It's very important to understand what is a need to learn these design patterns, what is a need to be aware of the existing design patterns, right? And why do we learn them and where to apply it. Okay, so that's a key part of it. You can see actually a diagram where you see a bug. Okay, so it's something like there is a bug that comes and you apply a particular fix, the bug keeps on repeating, you again put a fix, it again reoccurs, you again put a fix. There is no need to fixing this same problem again and again while you design a particular software or while you design a particular system. Okay, we do not have to reinvent the wheel. You do not have to find a solution to a commonly occurring problem that someone has already, or people who are working on the software design software systems know that that is a problem. Okay, so we are not required to reinvent the wheel. Instead, use a proven solution to the particular problem, and that solution is called design pattern. Okay, let's say you're working on an application. You do need to make sure that there is only one instance of database connection. Okay, so your application is connected to database, and you want to make sure that there is only one instance of the database connection that is available. Okay, you do not want to create multiple instances of the database connection. You just need only one instance. There are multiple ways of doing it. Rather, this is a commonly occurring problem, and to solve this commonly occurring this particular problem, there exists a design pattern called Singleton design pattern. Okay, so it's a ready-made solution to a repeated design problem. Similarly, there are multiple design patterns which are actually the solutions that you can apply to the commonly occurring problems in software design. So that's the real importance of knowing what are the design patterns. First, why the design pattern need to be learned. Second, what are the design patterns and where to apply, how to apply. Okay, now breaking it down, a design pattern typically has got four elements. One is a pattern name, which is like singleton design pattern, factory design pattern, observer design pattern, strategy design patterns. You will come to know, right? Next is problem. Problem is something like, if there is a problem, it actually tells you what is the scenario involved, meaning the problem will tell you when to apply that particular pattern. Obviously, only if there is a problem we can actually, it tells you, okay, this is the problem and this is when I have to apply a solution. So solution is of course a design pattern over here. So problem is when to apply the pattern. Now what is the solution? The solution is how the design pattern solves a particular problem. Okay, so we came across pattern name. What is a pattern? Design pattern name. What is a problem? What is a solution? And consequences. Obviously there are some trade-offs or side effects that you should be knowing while you apply one particular design pattern on a particular problem. Okay, depending upon the use cases. So understanding these elements helps you know when, where and why to use a particular pattern. So now we are clear about why to learn a design patterns. When you know the design patterns, you can look at a problem and think like, oh wait, I have seen this problem before. Instead of hacking a one-time fix, you can apply a well-structured, battle-tested solution, right? If you come across a particular problem, you don't have to fix it. Okay, just put a one-time patch over it, right? No, can think like, oh wait, I have seen this particular problem before. I'm going to apply a well structured, tested solution, proven solution, meaning I'm going to apply a particular design pattern for this particular problem while designing the software, right? So in the series we'll definitely go deep into one of the most or multiple popular design patterns like singleton, factory, strategy, observer, adapter and more. Also explained with the real world use case diagrams, hands-on code examples and all. Okay, so yeah, so we can apply solution to the commonly applied problems we're solving by knowing the design patterns in the software design. So this part is clear for you. uh, the next slide actually want to give you some theoretical idea about like the gang of four design patterns, right? um, when we actually talk about design patterns everywhere, we will actually come across a term called gang of four. It's actually four guys. Okay, the gang of four design patterns is being introduced in a book called Design Patterns: The Elements of Reusable Object-Oriented Software. Use Think emphasize the word reusable. Okay, elements of reusable object-oriented software. It's authored by four guys: Rich Gama, Richard Hem, Ralph Johnson, and John. So they provide a catalog of proven solutions. Okay, proven solutions to the common design problems in software development. And there are three types of design patterns: creational design patterns, structural design patterns, behavioral design patterns. Okay, you can think about this as there are multiple solutions and these solutions are being categorized, okay, based on whether you're applying that particular solution on a creational environment, like when you create new objects, right? This pattern address problems related to object instantiation and help make systems more flexible and reusable. It hides the complicated details of the how the objects are created, so you can you completely see, like, it mostly deal with the object creation mechanisms. There are multiple solutions, or there are multiple problems involved in creating an object, managing that particular object creation, right? Or building the object. So many areas around, object creation part. Okay, object instantiation and creation part. So a lot of problems that can occur, and obviously where there are problems you have proven solutions. So these design patterns are involved in the creational part, so we call it as grouped under like creational design patterns, which focus on the creation of objects. Okay, now we have structural design patterns, where, okay, so now you have got so many objects, you want to define relationship between these objects. Okay, so again, problems can occur when you want to define relationship between the objects. Or relationship meaning, like, see, understand this for creating flexible and reusable software architecture. Flexible and reusable, these patterns help you manage relationship between entities, making it easier to design systems that are both scalable and maintainable. Okay, so you actually, let's say you define the relationship between the objects, relation between the entities and everything, but there is a problem that, oh my god, that's no more scalable. There's tightly coupling and all, like it's no more scalable. Or you have you have actually defined the relation between objects in such a way that it is no more maintainable after few usage, like, you cannot maintain it. It's not a maintainable code. Okay, so meaning there are problems that actually comes if you poorly design the relationship between objects, right? So those problems are resolved using, again, proven solutions. So those problems are being resolved using applying structural design patterns. So we'll come across the structural design patterns whenever you want to design the relation between objects, or whenever you come across an issue where it is, it is related to the defining the relationship between the objects entities. The third category is the behavioral design patterns. Is basically describe how objects interact with each other, right? It involves responsibilities between objects, right? One object might be, dependent, or, there are a lot of ways. So whenever you want to describe how the objects should be actually interacting with each other, involves responsibilities between the objects, like, okay, one particular class is supposed to, do this particular responsibility, implement this particular responsibility, take care of this particular one. So basically you want to actually describe how the objects interact and involves the responsibility principles. And there are a lot of problems that occur, and you'll apply proven solutions, which is design patterns. We categorize those design patterns into behavioral design patterns. Okay, so as we go further onto the series, the deep into the series, we'll definitely get in touch with each of these creational, structural, and behavioral design patterns. Just to give you an overview of like what they are on a high level. See, creational design patterns, Singleton, we just gave a small example. You also see factory method, kind of like, we know, like it's kind of like a factory of objects. Creation, again, it's related to creation. Abstract factory, builder, again, creation of classes, like, setting the few fields, like you want to create a particular class, but, build with few preset fields and all, right? So creational involves like Singleton, factory method, abstract factory, builder, prototype. Structural, okay, structural involves like adapter, bridge, composite, decorator, facade, flyweight, proxy. Behavioral, where chain of responsibility, command, pattern, interpreter, iterator, mediator, memento, observer, set, strategy, template, method, visitor. Okay, so this is like a high level overview of the design patterns. Why need to know what are they, Okay, now I'm absolutely sure that you guys have developed an interest to know why I should be knowing the design patterns. You can actually design the software without knowing the design patterns, which will translate into a non-maintainable, non-scalable, lot of bugs, repeatable bugs, right? You end up putting patch one over the other. Okay, so that's more into that. Okay, so now just to summarize, okay, when we see the same problem happening again and again while designing systems, okay, we do not need to reinvent the wheel. Instead, use a proven solution. The solution is called a design pattern. Okay, so in this series we actually covered most of them, right? Fine. So before I wrap up, so if you are ready to level up your code quality, improve your architecture skills, and speak the language of serious developers, do stick around. Smash that like button, hit subscribe, and let's get started with the patterns, design patterns in detail, starting with the singleton from the next one. Thank you for listening, guys.